This video is on tree diagrams. I'm going to be doing the last problem that is more of a challenge problem, which is why it's sectioned off like this. This problem actually ends up using what's called conditional probability because of the way the question is worded. I'm going to go straight to the question real quick. What is the approximate probability that Jamal chose to get home by bus given that he arrived after 7 p.m.? This given part tells us something very specific, so when we do our tree diagram to find all of the information, when we find our probability, this given part is really important. So let's go ahead and try and make a tree diagram. So we have Jamal can choose to get home from work by taxi or by using the bus. If he chooses the taxi, he will get home after 7 p.m. 8% of the time. If he chooses the bus, he gets home after 7 p.m. 15% of the time. So we have taxi and bus, and we'll have getting home after 7 p.m. and getting home before 7 p.m. So we have our starting point. Again, he has the chance of taking the taxi or the chance of taking the bus. Now, after he takes the taxi or the bus, he'll get home. So from the taxi and the bus, he will be able to get home before 7 or he'll get home after 7. So I'll put before 7 and after 7. I can also maybe call this early and late. If I have to make out a set with letters, I might say that this is early, before 7, and after 7 is late. So when he takes the bus, he also has that chance of getting home before 7 or after 7. So now we can do our set. He would take the taxi, and he might be, like I said, I'll put an E for early. This would be taxi, and he would be late. He would take the bus, and he would be early. He would take the bus, and he would be late. I'm just using those because I have two B's in here. So two B's, I didn't want to mess anything up. So now we can go put our numbers in here. So it says if he chooses the taxi, he gets home after 7 p.m. 8% of the time. So after 7 p.m., he would get home at 8%, which is 0.08 or 800ths. Therefore, if he takes a taxi, he'll get home before 7 92% of the time. So that's 0 and 92 hundredths. If he chooses the bus, he'll get home after 7 p.m. 15% of the time. So that's 0 and 15 hundredths. So therefore, he would get home early or before 7 85% of the time, which is 0 and 85 hundredths. Then he says because the bus is cheaper, he uses the bus 60% of the time. So for the bus, he actually uses 60% of the time. So that's 0 and 60 hundredths. Therefore, he would use the taxi 40% of the time. So that's 0 and 40 hundredths or 4/10. So now, what is the approximate probability that Jamal chose to get home by bus, given that he arrives after 7 p.m.? So if we remember what probability is really what we want. What is it that we want? But over, we have to divide it by the total possible outcomes. So let's figure out what is it that we want. So we want Jamal to get home by the bus, but he has to arrive after 7 p.m. So that's what we want. So we want the bus, and we want him to be late. So we want bus and late. We want BL. That's the one that we want. Over the total possible outcomes. So all of the outcomes that could potentially happen for him to be able to, it says given that he gets home after 7 p.m. So we have to use that as saying this has to happen. He has to arrive home after 7 p.m. So what are all the ways that he can get home after 7 p.m.? What are all the ways he can be late? He can take the taxi and still get home after 7, but he can take the bus and get home after 7. So we want both of those. All the outcomes are him taking the taxi and being late, or he could have taken the bus and been late. So again, we can follow this path. All the possible outcomes are everything of that given. We just have to know that he has to arrive after 7. So the after 7s are following this path. After 7s are following this path. So we can figure out these values. We need to figure out bus and him getting home after 7. For him taking the bus and getting home after 7, that's 60% times 15%, which is approximately, it'll be 9%. So 0 and 9 hundredths, because again, it is just 6/10 times, it'll be 15 hundredths, which is 9 hundredths. Then we also need taxi and late and bus and late. Well, we already have the bus and late, which is 0 and 9 hundredths. Then we also want the taxi and late, which is that 40% and that 8%. So 40% times 8% is 30. It's not even 32%. That's like 3 2/10%. So we would have 0 and 0.032. Now this is an OR, so we could have both of these possibilities, so we would have to add those two together. So really, what we want is that 0 and 9 hundredths, or that 9%, out of 0.032 plus that 0.09, because we could have him getting home after 7 two different times. So when we combine that, we'll get approximately, when we use our calculator, we'll get approximately 0 and 0.738. So he's basically getting home, the fact that we want him to, he chose to get home by the bus, but he's gonna get home after 7 p.m. So the fact that he's taking the bus and he'll get home after 7 p.m., it's going to be close to 74% that he will get home by the bus and still be late. So again, this is a conditional probability because of that given that. Given that tells us that we have to have that outcome, that is the outcome we have to have. But there are multiple ways he could have gotten that outcome, which is why we have to know all of these. So given that, that's telling us that's our outcome we have to have. He has to get home after 7, but we still want him to do what it is we want. We want him to get home after 7, but using the bus. If it had said we wanted him to use the taxi, then it would have been different. So the denominator would still be the same because we wanted him to get home late. So then the total possible outcomes are still those two possibilities. Him using the taxi or him using the bus and still getting home after 7. So this is a little bit more of a challenging problem only because you have to focus on the fact that it says given that, and that given that tells you that your possible outcomes have to be using that information.